So in this video, I'll be going through some things that you may need to know for the IB MYP Sciences e-assessment, so generally any science. This is similar to the video I did for language and literature, where I'll be going through everything, but I'll only be going through criterion B, C, and D, because I think those criterions are the ones where people struggle the most, since criterion A is just the knowledge, the content. If you just study the textbook or your notes, you'll be able to answer them. So I think it's B, C, and D where people struggle the most. So starting off with criterion B, the first thing I'll be talking about is planning an investigation. Every single assessment, science assessment, has a question where they'll be asking you to plan an investigation. Usually it's 13 to 16 marks, around there, depending on how many things they ask you to write. But this is generally a list of all the things they could ask you to write. Identification of variables, which are the independent variables, dependent variable, and constant variables. A research question, hypothesis, list of materials, equipment needed, details of the method that will allow sufficient data to be collected, how the data obtained will be utilized to come up with the conclusion, a statement of any assumptions made, how you will ensure that your method is safe. This is generally everything that they could possibly ask for. There won't be anything more that they'll ask for from this. Starting off with the variables. When they say variables, they mean three types of variables. First is the independent variable, which is the variable that will be altered, the one that will be changed during the experiment. Dependent variable is the variable that will be measured. So you change something, and because you change it, something else will change, and you're measuring that. And then finally, the controlled and constant variables. So they're variables that you'll have to keep constant, the same, throughout the experiment in order to ensure fairness, so that the dependent variable, the one that you measure, is only affected by the independent variable and nothing else. And when you include controlled variables, you must include a minimum of 2 control variables. If you include one, you won't be getting the marks for including it. It's mentioned in the rubrics that you have to include 1 independent, 1 dependent, and 2 control variables. And then the research question, it's really very simple. Just make sure that you don't write a statement. You'll have to phrase it in a way where it's a question with question mark. So common ways of writing it, you can write it in any way, but common ways is, what is the relationship between the independent variable, whatever it is, and the dependent variable? Or what is the effect of the dependent variable on the independent variable on the dependent variable? And then hypothesis is, so if the independent variable changes any way, or increases or decreases, whatever, then the dependent variable will increase or decrease. So what's the effect that it has? And then this is because you mentioned a scientific reasoning behind the prediction. Usually hypothesis will be 2 to 3 marks, depending on how much elaboration they want. And then after that is materials or equipment. Usually the significant equipment that the question wants from you is not random equipment. They want equipment that you'll use to alter the independent variable. For example, you're changing the mass of something, then they'll expect an electronic balance to be one of the equipment you include. And then what equipment are you using to measure the dependent variable? If you're measuring temperature, they'll expect you to include a thermometer. And how you control the control variables. You mentioned 2 control variables. You have to include equipment that enable you to control both of those control variables. Anything else required in the procedures may be included, but they probably will not get you the marks. The main marks will come from the equipment that affects the 3 variables. And just some common equipment include an electronic balance, measuring cylinders, pestle mortar, beaker, stopwatch. Measuring time is a common thing. And generally, as a dependent variable, time is common. It's also common as a constant variable, something you have to keep constant. Thermometer, there's many others, depends on the experiment. How to collect sufficient data. If they ask you can directly write it like this, but you could also incorporate it in the procedures however you'd like. But in some manner, you have to mention that you'll be conducting 3 trials and you're going to use it to obtain an average in order to collect sufficient data. And you'll have to use proper measuring equipment, as I mentioned earlier, to change the independent variable, to measure the dependent variable, and to control both the control variables. And you must have at least 5 increments in the IV, and they have to be regular increments. So say you're doing temperature and you start from 20 degrees, you should go from 20, 40, 60, 80, 100. You shouldn't go 20, 30, then 35, then 50. It should be regular increments. And then procedures. For me, I like to mention the 3 ways in which I collect sufficient data separately, and then I write the procedures as like 1, 2, 3, 4, 5 steps to make it easier to understand. But you can also write it in a paragraph format, whatever you're comfortable with. But however you write it, the rubrics mention that the procedure should be stated in a way in which someone can replicate it. But of course, it doesn't really have to be to that extent. You just have to make sure that you mention all the 3 variables, and accordingly, you mention all the equipment that will be utilized with accordance to all the variables. And you have to also mention the usage of at least 3 trials. And of course, you have to mention that you're gonna repeat the set of experiments for all the increments of the independent variable. And at times, depending on what the experiment is, they may ask you what assumption can you make about the experiment. This usually applies mostly to chemistry, I think, because a common assumption made is that the reaction may not go into completion. That's usually a common assumption. Otherwise, I've never seen this question in any other science like biology or physics. I've only seen it in chemistry. And another common thing to ensure safety, more common in chemistry again, would be commonly wear goggles, lab coat, gloves. And it's especially easy if the experiment involves any sort of acid, because you can easily say the acid will come into contact with your eye, skin, so you wear all these things. So the way you answer it, you have to mention what the safety precaution is, and you have to mention why it's taking. As in, you have to mention acid is corrosive and cause damage to skin. So what I'm doing here, because I have questions to all 3 sciences, chemistry, biology, and physics, I included sort of questions for a full Criterion BC question for all 3, as well as a sample answer that scored full marks. So you could try out the question and see the answer to see to what extent you're able to answer it on your own. And these are all past year questions, so it should be helpful. This is the question for chemistry. And this is the sample answer for chemistry. As you can see, you don't really have to write it to that much detail, but you should always include everything in order to score full marks. And this is the question for physics, as well as the sample answer for physics. And finally, a question for biology, as well as a sample answer for biology. And moving on to Criterion BC, it's mainly towards Criterion C, in which there's the analysis of any investigation that the question gives you, or utilizing any data from existing experiments. So instead of you planning an experiment, the question sort of gives you more data, and you analyze the data, analyze the experiment, the investigation. So a common question that's always asked is to organize data into a table. So whenever you do this, you take 1 column for the independent variable, and usually they'll always give you trials, so it'll usually be 4 columns for the dependent variable, in which you include the 3 trials and a calculated average. And you always have to include units in the column headers. For here, I included seconds for time, but there's no unit for the independent variable. And all values must be in the same decimal place. So one thing that I noticed that e-assessment likes to do is whenever they give you pictures of the raw data that you have to use to include in the table, they always like to make it so that the data is either out of order, or they have multiple units and varying decimal places. So that's why usually this question has around 5 marks. They try to change the order of the independent variable. So what you should do is you should make sure it's a consistent increasing order, 1, 2, 3, 4, 5. They mention the numbers, but it's out of order. And they have different units. One is in minutes, seconds, and you should convert it to a consistent unit. Which unit you choose doesn't matter as long as it's consistent. And of course, you should have the same number of decimal places. And then presenting data on a graph, independent variable on the x-axis, dependent variable on the y-axis. You have to have a title, y-axis against x-axis. And whether you make a bar graph or a line graph depends on what the independent variable is. If the independent variable is qualitative, you create a bar graph. If it's quantitative, you create a line graph. E-assessment usually will mention these things in the question itself. They'll mention, please label the axes, include a title, but it's good for you to know as well. And one thing that you may want to study before the exam are all the hazard symbols, because questions may be asked regarding the meanings of hazard symbols, or they may ask you to choose like appropriate hazard symbols for a certain situation or for certain chemicals. And then common questions include commenting on the validity of predictions or hypotheses. So for this type of question, they'll usually give you the data, or they'll go through the process of you making the table, drawing the graph and everything. So by then you'll have all the data either in a table or graph format. So you mention whether the prediction is valid or not. And based off of the data and graph provided, you explain the trend between the independent and dependent variable. So as the independent variable increases, dependent variable, blah, blah, blah. And you provide a scientific reasoning for that trend. And if the trend matches the prediction, then you mention that the prediction is valid. If the question asks you on this, it'll usually be 3 marks. And another thing is, generally, if a question asks you to analyze a graph for anything, first thing you have to mention is, of course, the relationship between the independent-dependent variable, and then scientific reasoning. That's generally the main thing you should be including. And another question that I've seen commonly asked is, one of the predictions and hypotheses they like to say is that the relationship is directly proportional, or the relationship's inversely proportional. So for directly proportional relationships, the line should be a straight line graph, and it should also be passing through the origin, and it also should be increasing regularly. So as the independent variable increases by a certain amount, for example, as the independent variable doubles, the dependent variable should also be doubling. But for inversely proportional relationships, that's not the case. So you can also consider this. You can also take note of this, because the question may ask you that. And they may also ask you, okay, like, experiment is all done, so how can the experiment be made to be more reliable? Common answers would be, you can increase the number of data points collected in the range, so you get a more concrete and certain relationship between the variables, the independent and dependent variable. And maybe you can suggest different apparatus to ensure accurate data. And of course, the most common answer, unless specified anywhere else, would be to increase the number of trials and to calculate an average and provide a justification, because this question is usually 2 marks, in which you identify and minimize the impact of any random errors that may have occurred, so you obtain more reliable and accurate answers. And then sometimes they'll ask you to give an extension of an experiment. This is usually just 1 mark. They don't really expect you to explain beyond that. But one mistake people commonly make is that they mention changes that could be made in the procedures to make the present experiment better. But they're asking what could possibly be investigated beyond this to obtain data that is so relevant to the problem or real life situation behind the investigation. Because e-assessment always provides a sort of a real life situation before they give you the investigation. And then that's it for Criterion BC. And I'll also be going through Criterion D and one world factors. So this is basically the rubrics for Criterion D, just for you to see. Strand 1, explaining the ways in which science is applied and used to address a specific problem or issue. So it's mainly the scientific theory behind something, and discussing and evaluating the various implications of using science and its application to solve a specific problem issue, so connected to strand 1. And strand 3 is to apply scientific language effectively. Strand 4, document the work of others and sources of information used. So in this sense, if sometimes it's quite rare, but the question will give you a source to use. So in that sense, you have to take information from the source and use it to support your points. And when you do, you should be including in-text citation, and you should be referencing the source towards the end, because they'll give you sufficient information in order to reference it. So just to show how you can use one world factors and scientific theory in order to answer a Criterion D question, I'll be giving an example of one question. So the question would be, should organ donation be compulsory? So the question will normally list out things for you to write, but I'll just be focusing on all one world factors and generally everything for this question. So focusing on strand 1 and strand 2, for this specific question, what you can write is you can write first the definition, what is organ donation, and just a brief explanation of the requirements a person must meet to both donate and receive an organ. And of course, if the source is included, you include in-text citations, and the source must be referenced towards the end of your analysis. And for strand 3 and 4, I'll be focusing on going through all 6 one world factors to see how you could possibly take this one question and think of it from a lot of different perspectives. So I mentioned the one world factor and the definition, as well as examples of points and perspectives that you could discuss from. Generally, the more common one world factors are social, economic, and environmental issues. Political comes time to time, and ethical as well. I've never seen cultural in a question, but the common ones are these 3, and time to time you may see political or ethical. I've never seen cultural before, but I guess it depends on the question. And okay, starting off with social. So Criterion D, you focus on both sides. You focus on advantages and disadvantages, because it's usually the command term used is usually discuss or evaluate. For discuss, there's no requirement to mention both advantages and disadvantages. But if the question says to evaluate, then you must include both advantages and disadvantages. But of course, the question itself will specify to include that. So for social, the pros would be, of course, increased lifespan. The receiver gets the organ, they can live for longer. And there's a high chance of recovery rate. Of course, you see whether the organ is compatible or not. So there's a high chance of it working and the person being able to still live after that. And there's also the argument everyone deserves a second chance to live. And any emotional aspects, this also falls under the social one world factor. So you can talk about the people surrounding the person being the person who's receiving the organ. So less people have to suffer from loss of loved ones. And you'll also be able to get a stronger medical industry because more research is focused on this. Maybe there's more of a budget given to allow organ transplants. So this generally improves the standards of living. And cons, not every patient has the time to wait. Some people may be in more of a dire situation than others, which brings up the argument, well, how should hospitals prioritize patients? And the patient's body rarely they may reject the organ, causing premature death. And by chance this occurs, loved ones of the receiver would have to face the pain. And by chance, even if the receiver ends up well, the loved ones of the deceased donor may not be able to accept the situation, even if the donor was supposed to die already. Their loved ones may not want them to transplant the organ, and the living donor may suffer consequences if the organ is not a perfect fit. And then moving on to economical, one more factor. The pros would be, again, the boom to the medical industry, more job opportunities, and an increased lifespan equates increased manpower. And cons, of course, is expensive. Not every patient can afford it. And cultural cons are that certain religions advocate life or fate being God's will. So they may believe that you extending your life or getting organ donation defies God's will. And then for the ethical aspects, there's the pro that everyone has a right to live, but there's also a con, as mentioned earlier, who decides the priority of patients, who gets to decide who's more important to receive the organ first, because there will always be a lack of organs that can be, there will always be a limited supply. And this could increase the opportunities for illegal black markets to sell these organs, which will cause ethical issues, obviously. And there's nothing for environmental, but for political, it could go back to the issue of the illegal international black market because it relates to the government or public affairs. So this is generally the way you can talk about each single one world factor. Of course, you can look at the specific definitions to see exactly what it is. But yeah, social mainly focuses on your standards of living, emotional aspects, just generally your life. Of course, economy focuses on the money, cultural, religion, ethics, moral values, what's right or wrong. Environmental should be quite self-explanatory. Political, anything involving the government, public affairs. And similarly for Criterion BC, I'll be providing a question for all three sciences, as well as an answer for the answer that I gave, which scored highly, for you to take an example of certain perspectives that could be considered that you may not have considered. So this is for chemistry. And this is a question for physics. This question is quite a bit long because it's one where you compare different options for producing medical images, and you decide which way of producing medical images is best. So the first is ultrasound, X-ray, and then CT scan, MRI. And then this question focuses on you choosing which one is the best equipment. So you discuss and evaluate according to that. And this is the answer that I wrote, in which I connected it to the current COVID-19 pandemic. And then finally, the question for biology, as well as my sample answer. So that's everything I have to say for all sciences. I believe even if there are sciences beyond these three, these aspects of Criterion B, C, and D would be similar due to the nature of the subject. So I hope it helps everyone taking any sort of science.